I know we only have two solve for x problems that we have space for here, I think. Yeah, solve equations. I'm going to do three of them just because I think we see these things often enough, and it would be good to have some practice. And these are three distinctly different type of problems. This is a third term here. We look at these and they sort of dominate the landscape, but this 2 over 1 it's another problem that involves fractions. That's going to have to be involved when we get rid of these fractions. Okay, if we understand that our common denominator is x plus 1, and I multiply through by x plus 1, I need to not only do that here and here, but I also need to include this guy in the middle, x plus 1. And that's going to have to be distributed. That's really where the work happens, because this just goes away. I'm left with 3x plus 2. This just goes away. I'm left way over here with a 2x plus 3. But in the middle, oh, and it's a minus, and you got to be careful of that. And we'll get to that in a second. You're multiplying through by everything. This is very commonly the forgotten little deal here. But distribute that too, and so you get a 2x plus 2, because 2 times x and 2 times 1 is going to give you both of these guys. This is obviously, or obviously, it's not obvious, because a lot of you make this mistake. You'll only apply that negative to the 2x. So I would do as I normally do, and I would change that to a plus and distribute that negative as soon as you can. So what you'll see here, first of all, is that those like terms are going to go away, and you end up with a 2 minus 3, which is a negative 1. Okay, over here, you've got a 3x plus 2. Well, if you subtract the 2 from both sides, you end up with a 3x equals negative 3, so x equals negative 1. And you think, oh, I'm so great. I did this problem, and it's so right. And you are. The math is right as you get to that point. But what you need to make sure you'll notice is that if you plug that into the original problem, you end up with a negative 1 plus 1 in the denominator of two different fractions, both of which give you 0 in your denominator. So that should show you that, in fact, we have no solution here that works. Okay? You have to go back and plug it in. You have to make sure you catch that. Okay? You look over here on number 30. Your common denominator is 5x. Again, we have three terms. We're going to multiply by 5x in each of the three different fractions. Each of the three fractions will be reducible to some degree. Your x's cancel. 5 times 9 is 45. 5 goes into 5 now. The 5's cancel, but you still have that 11 and that x. So plus 11x. Equals, you cancel your x's. You have 5 times 31. That's 155. Okay, 5 times 1 is 5, and 5 times 3 is 15. So that's what we're looking at there. Okay, you subtract 45. I almost divided, shame on me. Subtract 45, you end up with 11x equals 110. Divide by 11, you get x equals 10. Now, you go back, that's not going to make any issues with our denominators here. So x equals 10 is a legitimate solution. Finally here, if you factor this to get x plus 2 and x minus 2, your common denominator is both an x plus 2 and an x minus 2. Now some of you might, like we were reducing fractions earlier, call that an x plus 2 over x plus 2. And that would work, but you're doing probably more work than you need, because if you know this is our common denominator and we can get rid of our fractions, that's what we'd like to do. So multiply by x plus 2, x minus 2. And in reality, you're not multiplying that at all, x plus 2, x minus 2. You're canceling all of those, but the nice thing about that is you're just left with this, without a fraction. Now, we have a little bit of work ahead of us still, because even when you cancel these x minus 2's, you still have to FOIL this stuff out on this side. And that's, you should be FOILing by now without much of a hitch. X times x is x squared. The outer term is going to give you a plus 2x. The inner term is going to give you a plus 3x. I'm sorry, I'm doing some stuff in my head that I shouldn't. Plus 1x. And then lastly, it should be a plus 2. Okay? You have a lot of terms, a lot of like terms. But you want to make sure if you have x squared and x and a constant on one side, you want to move it all to one side, set it equal to 0. So we're going to subtract the 3x from both sides. We're going to subtract the 6 from both sides. And you'll start to see something take shape here. 0 equals, you have an x squared, 2x plus 1x minus 3x is 0 x's. So you don't have any x's left. What you do have then is a minus 4. So if you factor this, you get x plus 2 and x minus 2 equals 0. You have two solutions, x equals 2 and x equals negative 2, both of which, by the way, will give you 0 in the denominator of a fraction. So here we actually have two extraneous solutions, and it's another no solution. So keep an eye out for that. Don't just get your answers and move forward. Get your answers, look at your denominator, and make sure you ignore or you eliminate your extraneous solution.